Density of sodas. Calculations. In this video, we will discuss the calculations for the density of sodas experiment. The calculations will be very similar to those for the burette in the previous experiment. Please remember to show all of your calculations. The data used in this video are data that I obtained by performing the same experiment. In order to determine the density of each soda, we will need two values. First, the volume of the soda, and second, the mass corresponding to that volume. As in the first experiment, we use the burette technique to measure these values. First, we must determine the volume of soda delivered for each trial. Next, we will determine the mass of the soda. And lastly, we will divide to obtain the density. The first calculation is to determine the volume of cola delivered by the burette. In this first trial of the cola, the initial burette reading that I made was 13.48 milliliters, and the final reading was 23.50 milliliters. Therefore, the volume of soda delivered is calculated to be equal to the final reading minus the initial reading, or in this case, 23.50 milliliters minus 13.48 milliliters, giving a volume of 10.02 milliliters. For my data, the other two trials for cola resulted in volumes of 10.01 milliliters and 10.01 milliliters. Next, we need to calculate the mass of cola delivered by each trial in the burette. In the first trial of the cola, the mass of the empty beaker was found to be 28.490 grams, and the mass of the beaker and cola was 38.981 grams. Thus, the mass of the soda delivered is calculated to be the mass of the beaker and cola minus the mass of the beaker, or 38.981 grams minus 28.490 grams, giving a mass delivered of 10.491 grams. For my data, the other two trials for cola resulted in volumes of 10.440 grams and 10.410 grams. Now that we have the volume and the mass, we can calculate the density. In the first trial of the cola, the mass of the cola was determined to be 10.491 grams, and the volume was found to be 10.02 milliliters. Therefore, the density is calculated as the mass of cola divided by the volume of cola, or in this case, 10.491 grams divided by 10.02 milliliters, giving a density of 1.047 grams per milliliter. For my data, the other two trials for cola resulted in volumes of 1.043 grams per milliliter and 1.040 grams per milliliter. The next step is to calculate the average density. Recall that the three values of the density of cola were found to be 1.047 grams per milliliter, 1.043 grams per milliliter, and 1.040 grams per milliliter. Thus, the average density is calculated as the sum of these three, 1.047 grams per milliliter, plus 1.043 grams per milliliter, plus 1.040 grams per milliliter, all divided by 3. The numerator becomes 3.130 grams per milliliter, again divided by 3, giving an average density of cola of 1.043 grams per milliliter. And lastly, we can calculate the standard deviation of the densities for cola. First, we must find the deviations of the individual readings. For the first reading, D1 is equal to 1.047 grams per milliliter minus the average value of 1.043 grams per milliliter. This gives a deviation of 0.004 grams per milliliter. For the second trial, D2 is equal to 1.043 grams per milliliter minus 1.043 grams per milliliter, giving a deviation of 0.000 grams per milliliter. And lastly, for the third trial, D3 is equal to 1.040 grams per milliliter minus 1.043 grams per milliliter, giving a deviation of negative 0.003 grams per milliliter. Next, we have to calculate the square of the individual deviations. For the first trial, D1 squared is equal to 0.004 grams per milliliter squared, which is 1.6 times 10 to the negative 5 square grams per square milliliter. D2 squared is 0.000 grams per milliliter squared, which is again 0.000 square grams per square milliliter. And lastly, D3 squared is equal to negative 0.002 grams per milliliter squared, which gives a positive 9 times 10 to the negative 6 square grams per square milliliter. We can now complete the standard deviation for the cola densities. Recall that the standard deviation S is equal to the square root of the sum of the individual deviations squared divided by n minus 1. In this case, the numerator becomes 1.6 times 10 to the negative 5 square grams per square milliliter plus 0.000 square grams per square milliliter plus 9 times 10 to the negative 6 square grams per square milliliter, all divided by 3 minus 1. This simplifies to 2.5 times 10 to the negative 5 square grams per square milliliter divided by 2, all under the square root sign. When we divide, we get 1.3 times 10 to the negative 5 square grams per square milliliter. And lastly, we can take the square root, which results in a standard deviation of 0.004 grams per milliliter. You will now repeat the same calculations for the Diet Cola. The calculations are performed in exactly the same manner. Be sure to show your calculations for each step in order to receive full credit. Report guidelines and a data sheet will be posted on Canvas.